Welcome to our lesson on mains electricity, where we're going to be looking at the plug and how we connect to domestic electrical supplies. So we're going to be completing these two booklet pages, which you can find on revisingscience.com if you haven't already got them in front of you, and that's the information we're going to be filling in as we go. So we'll start off with the first page, looking at direct and alternating potential difference. So where we're looking at domestic electricity supplies, we're mainly focusing on the electricity supply to your house. Now obviously that electricity supply has to come from somewhere. It comes from a power station where the electricity is transferred from one form to electrical form that we can use, and then it's distributed around the country using the national grid. The things that you need to know is that the mains electricity is an AC supply, which stands for an alternating current supply. Have a look at our other video on electricity to find out a little bit more about that. And the domestic electricity supply has a frequency of 50 Hertz and a voltage of 230 volts. Both of those numbers you need to know, so make sure you learn them, add them into the booklet. So going back to that point about AC current, there are two types of current: AC, which stands for alternating current, and DC, which stands for direct current. In those two graphs below, on the one on the left is what we call direct current, and the one on the right is what we call AC or alternating current. If you look at the one on the left first, this is direct current, because here the current flows in only one direction, and that's why we call it a direct current, or DC. So on the graph you can see it's just in the positive side, it's on the positive side of the 0 volts, and it would always maintain there. If we have a look at the graph on the right, this is our alternating current, the one that's going up and down. Because if the current constantly changes direction, then we call it an alternating current. So if you look at the graph, it's going from the positive side through the 0 down to the negative side, then back up to the positive, down to the negative, and etc. It's swapping between them. So that's our alternating current. Okay, we're going to move on to the second page where we look at the plug, and again check out our video to see a bit more about the plug in detail, but this is the information that you need to know. So to connect to the national grid, most electrical appliances use a plug that plugs in, and it's got this cable that runs from the plug to the electrical appliance. Now we call that cable there a 3-core cable, and the reason being it's got 3 wires inside it, and you can see them there represented in the plug with the 3 different colours. So you've got the blue wire, the green and yellow wire, and the brown wire, and they're the important bits that you need to know about. So the blue wire is called our neutral wire, the green and yellow wire is the earth wire, and the brown wire is the live wire. When putting them into a plug, I think it's really easy to remember which way they go. Remembering the blue and the brown go off to the left and right. So the blue wire, the second letter of blue is obviously an L because it goes to the left, and the second letter of brown is an R, which indicates right because the brown wire goes off to the right. So make sure you know the colours and that you can label them in a plug. So let's have a look at the wires in a bit more detail. So the live wire there carries the alternating potential difference from the supply. So the live wire is taking the current from the supply to your appliance. Your neutral wire, that completes the circuit, so it's taking the current back. And the earth wire, the green and yellow one there, is a safety wire, which will stop the appliance becoming live. You also need to know the numbers of the potential difference that will flow through them. So the live wire, the brown wire, has a potential difference which is around about 230 volts. That's the difference between the live wire and the earth. The neutral wire, the blue wire, is at close to or exactly at 0 volts, which is the earth's potential. And the green and yellow wire, which is the earth wire, is at 0 volts most of the time, and it'll only carry a current if there's a fault with that electrical appliance. So as well as knowing about the parts of the plug, you also need to explain why these situations could be dangerous. So firstly, why is it that a live wire can be dangerous even when a switch in the main circuit is open? Well, the reason for that is that if you touch the live wire, you can complete the circuit between the earth and the live wire, giving you a shock. So the 230 volts potential difference of the live wire, the low voltage, close to 0 voltage of you and the earth, it's going to jump across, and that can give you a shock. And then finally, the danger of providing any connection between the live wire and the earth wire. Well, if you provide any connection between the live wire and the earth wire, you're going to complete the circuit, and again, this could cause a shock or an electrical fire.